Hi, this is Jeff from the Ozark Mountains. That's in Missouri, in the USA. We're working on our VIC-20 again today, and you might remember we started with a case that kind of looked like a banana, and we got it back to, well, close to the original color. It's not perfect, but hey, what is? In this episode, we're going to concentrate on getting the board running. We'll do a little more repair work on the case to get it functional and help it last hopefully another 40 years. And then we'll have some fun with our VIC. Let's get started. Thanks to PCBWay for sponsoring this episode. They offer an excellent quick-turn PCB prototyping service, which now has a free upgrade to the 150-160 temperature range. They also offer a wide range of services that allow you to go from idea to a finished product, including CNC machining, 3D printing, injection molding, PCB assembly. Go on over to PCBWay.com/OEM to find out more. Before trying to power on our circuit board here, I like doing a few checks to make sure that there's no shorts or anything obviously wrong that's going to cause a problem or blow a fuse. On these AC input VIC-20s, the 9 volts AC comes from our inlet here. One leg goes through the switch to the rectifier, the other goes through the fuse and to the rectifier. And from the rectifier, it goes into the 5 volt regulator and out onto the rest of the board. Now we can confirm which side of this regulator is the 5 volt output to the board with a simple ohm meter test. So I will put this here. I'm guessing this is the output, and I'm going to go to the highest pin on one of the ICs that's powered by 5 volts. Yep, and we can see our meter went to 0 ohms. That's definitely the 5 volt output. And conversely, we can go here, which is the 5 volt input, and go over to the positive leg of the rectifier, which is just down here in the corner. There we go. I gotta hold it there. Yep, that is the 5 volt input. So we know which side is our 5 volt output, and I'm going to check from the 5 volt output now to ground, which is one of these pads on the side where our regulator was. About 1.65K, that's fine. It's not shorted out, it's not low, so everything should be okay, and we should not blow a fuse. Now, of course, I don't have a 5 volt regulator mounted, and our switch here is stuck, it will not move. So I am going to power this with a bench power supply to start with. That way we can see if it's running, and we can check how much current it's drawing and get a better idea of the state of health of this thing. So let's get that hooked up so we can try it. One thing I did before plugging the socketed chips back in was hit all the connectors and the sockets with some deoxit and cleaned up the mess. That makes... I checked the big capacitor here with the component tester, and it tested okay. I'm not sure about this one. It was actually testing high, but the ESR was okay. In other words, it was testing high in capacitance, but the ESR was okay. I'm guessing he's probably okay, but since he's right under the heatsink, I'm going to go ahead and replace it just for a little preventative maintenance. I think the rest of these are okay. There's no signs of leakage, and some spot check on the values show they're fine. I have, you can just see these clip leads here. I have connected my bench power supply to one of the bypass caps, which goes across ED1 here. That's an easy way to power the board with 5 volts directly. The only other thing on this board, the reason I can do that is the only other thing on this board the 9 volt goes to is part of the cassette motor circuitry here. There's a crude voltage regulator for the motor voltage, and it goes directly to the user port. Since we don't need any of those things to make sure it runs, we can just power the board directly with 5 volts. Now I'm going to turn on the bench power supply, and I've got it set to 5 volts. 1 amp current limit, and we'll hit the output and see what happens. Yeah, it's drawing more than 1 amp just in its idle state, so we'll say about 1.5 amps. And holy moly! So it's drawing 1.25 amps basically. And looky there. Whopping 3.5K free. Can you believe it? Now, of course, we haven't checked the serial interface, user port signals, joystick input, things like that. We've got all that left to do. But at least the basic functionality is okay. We've got interrupts going because we've got a blinking cursor. We've got video output. I still need to check sound output. It's reporting the correct amount of RAM. Now, the next thing we need to do on the circuit board itself is take care of this stuck power switch and replace our voltage regulator. And I've got a different type of regulator to pop in here, thanks to a tip from one of Chuck Hutchins' videos. So we'll get into that shortly. So I've got the soldering iron warmed up so we can take the switch off, but I think the first thing I'll do is go ahead and replace this one capacitor. And now we will try to get our power switch out of here. I think it's just these two. Nope. That holds it down physically. This is the electrical connection here. Just adding a little fresh solder, which helps it be removed a little easier. One, because you've got a little more flux in there, and two, because you're preheating the joint. And again, with these big pores of copper in here, that can be a little tricky. As I'm heating that, I'm watching the solder heat and flow out like this. You can get an idea of how hot the joint is and when you can try to suck it off of there. Just used a little pliers here to unstick it from the side of the hole if it's stuck. There we go. And we've got our switch off of there. It's got two posts here which just hold it physically. And it's got some pieces here that are crimped in holding it together. Oh, I applied heat and that freed it up. I imagine that's full of dirt inside. So I think what I will try to do is get under these guys without stabbing myself. Now it's interesting, it's bending the whole side here rather than just straightening these guys up. There we go. Okay, now we'll slowly slide that apart. Okay. We can go ahead and straighten up these tabs. And okay, there is a little post sticking out the back of the switch. A little plate that looks like it's rocked back and forth. And I see a little button just here, which is toward the leg that's more toward the top of the switch. Okay. Yeah, you can see how dark that plate is. And I don't know if you can see that the contact right here. It's supposed to be nice and brass or silver colored, and it is black. Got a brass pin here. Well, that's doing a pretty good job. Well, let's try to start with the least destructive method first. Yeah, that did a good job polishing that up. And then we've got this piece. Yeah, that polished up really good. So now what I'll do is get some alcohol and a Q-tip and clean this out as good as I can. Clean out the inside of this switch now. Oh, that cleaned up nicely. Sometimes when you take a switch apart, you never know what's going to happen. Oh, there is still some white paint in that little hole there. Each hole is also full of dirt. Yeah. Wow. That turned quite white, didn't it? And we don't want to forget about the metal frame here. It's interesting, there's not really a separate spring in here. Just all with this rocking piece. Okie doke, reassembly time. So I sprayed a little deoxit on this end of the Q-tip. I'm just going to brush it over the contact areas. I'll drop the contact back in there like so. And on the back of this, put a little dab of lithium grease. Put some on this piece too. And we'll put the... Okay, make sure our contact is centered in there. Make sure everything's rotating like it should. There we go. Okay. And we want the little pokey bits to go toward where the other pokey bits back here are. Slip him on there like that. There we go. Using the pliers as a ledge so I can push down against it. Pull those over, rotate this around, and do the same thing from the other way. There we go. You know, I wonder if I put that button in there the right way. I don't know. It was so dirty before, I don't know which side the dot was on. But, yeah, that makes sense. Because when you rotate it this way, it makes the contact here, and that's where the dot is. On. Okay. Here we go. That's on. That's off. Oh, you know what? I think I got the dealy bob there backwards. I don't know if I risk taking it apart again. What do you think? Okay, of course I had the part with the dot on the wrong side, so I took it back apart and I fixed it. Now we'll go ahead and get Mr. Switch reinstalled. I'm just holding it from the bottom. For these big joints like this, you need to use a wide enough tip, not a little pointy tip. There we go. I could have used a wider tip for this, but this was in the iron. This is kind of a medium chisel tip. Maybe a 3mm width. Okay. And we've got a switching switch. I will clean up the solder joints here, and then we'll worry about our voltage regulator. I guess since this is kind of working, we can start putting it back together. Now this cover here slots in kind of like that. And there are a couple of screws that go up from the bottom like so. And we've got our cover on this side for our connectors and switch. Just being a little difficult. Oh, hey, that's because it goes like that. Just below the board. Ah, that was quite easy once I put it on there the right direction. Now, getting to the point we need to put the voltage regulator on. Well, it came with this LM323K on here, which is a 5V 3A regulator. It is a linear regulator, which means it does a really good job at regulating. The output voltage is nice and smooth, but it's not very efficient. Why is that? Well, when we had this VIC-20 running, it was drawing 1¼ amps at 5V DC, which is about 6¼ watts. And our power adapter here is going to put out, 10-ish volts under load. And with a linear regulator, the voltage, or the current in, is equal to the current out, so we're going to have 1.25 amps at 10 volts AC going in, for a total of 12½ watts. Well, 12½ watts minus 6¼ watts coming out for 5 volts means that we're dissipating another 6¼ watts as heat, which is why we need this big honking heat sink right here. The higher the input voltage in relation to the output voltage, the worse this is. But the nice thing about linear regulators is they're simple and provide a very smooth output. So what we can use instead is this little guy, which is a switching version of this. I found out about these from Chuck Hutchins. He did a video, which I will link to in the description below, putting one on his VIC-20, and I thought it was an excellent idea. These aren't too expensive. And, rather than 40 or 50% efficient, these guys are more like 80+% efficient. So we're going to generate very little heat. Now, Chuck went to the trouble of measuring the temperature before and after, that type of thing, and the current before and after. So I will refer you to his video for that. I'm just going to copy him and use this PSU5 regulator in place of the LM323K, and I will put a link to the company that makes these in the description down below. The first thing we need to do is pop in our screws from the bottom here. That is the wrong screw. Then we can pop the heat sink in there. Now technically we would not need this heat sink with this guy because it's so efficient, but it looks the part. So I am going to go ahead and put it back on there. And since we're going to have the heat sink there anyhow, we'll add just a dab of heat sink grease to let the heat sink do its job. Just put a little. Now, you can't put these guys on backwards because the pins are not centered. We just talked about that earlier, but this is marked in and out. And we can just set him over there so it goes over the screws. It goes down through the holes in the board, like so. We have lock washers. So there's jobs you need 3 hands to do. I always figured out if we had 3 hands, we'd invent jobs you need 4 hands for. Just the way it kind of works out. You notice this guy has this teeny weeny little pot right here. This is a trimmer, meaning you can adjust it to get a little over 5 volts if you need that. It's not something you want to adjust on all the time. It's not made for that. It's made to tweak it just perfect and then leave it alone forever. So for this, we're going to hold the nut driver on one side, screwy driver on the other. Snug them both up. These don't need to be excessively tight here. We are just clamping down to a circuit board, but there we have our nifty switching voltage regulator in place. Okay, there we got him on there, and we need to slobber this guy in place. And I'll trim those pins. Going to clean up my mess from soldering here. Alright. Then we also have a heat sink here for the rectifier, which will go like so, and it clears the switching regulator in there. And we can almost get to the tweaker at the same time. That's convenient. I think for now I'm going to leave it off so we can test this. I'll measure the 5 volts to make sure it's okay, and then we can pop this cover on. Okay, I have our 9-volt AC transformer back here. It's hooked up to the VIC. I did measure the output of the transformer by itself. Unloaded, it was about 11.5 volts, which is what it says on the label. The power switch is in the off position, and I've got the meter hooked up to measure the 5 volts, so we'll go ahead and give it a shot and turn it on, see if sparks shoot out. And no, sparks do not shoot out. You can't see the screen up there, but it says CBM Basic version 2, 3583 bytes free. You can see we've got about 5.2 volts, which is a little more than we need. And I'm going to run this down to about 5.1. That's pretty good. Okay, and now we've got a nice steady 5 volts for our machine. It'll be generating very little heat. Now I'm going to put this other heat sink on, and then we will plug in a cartridge and a keyboard and a joystick and see if we can play a game. I'm doing a voiceover here because I forgot to turn on my microphone. I've got a chop lifter cartridge in here. I tried several cartridges and they didn't work very well. They weren't very reliable. I'll show you in just a second what I did to fix that. First, let's fix this nasty looking display. What I'm doing here is adjusting R7 on the circuit board to properly adjust the color to take it from this kind of dark muddy to a nice bright like it is supposed to be. Then I tried to actually play some chop lifter, and well, yeah, there's no sound or anything, but it's okay because it wasn't that exciting because I really stink at it and most other video games. So the problem I was having originally with cartridges is sometimes they would make contact and start to work, and a lot of times they would just lock things up. And even though I had squirted some contact cleaner in there, of course, if you're not physically abrading that, wiping it with something, you're not getting any of that dirt off of there. So the first thing I tried was a bit of folded up paper and stuck in here like this. This is not the easiest thing to do with paper. It's kind of like pushing a wet noodle. But you might just be able to see there how it got some dirt off of there. And then I found a piece of cardboard from a USPS small flat rate priority box. That is about the same thickness as a PCB. Soak that with some contact cleaner like I did the paper. Just go through like that. And this is a little harder to see the dirt on, but it also got some dirt off of there. And that cleaned up the contacts, and the cartridges worked really well. And you'll see I also went ahead and put our 9-volt AC line back over to the user port on here. And I guess now we could go ahead and try to plug in a SD to IEC and check that the serial communications is working fine. That would be something to do before we button it up and put it in the box. Okay, I've got SD to IEC hooked up here, and we should be able to do a load file browser, -8, and run, and if all goes well, it'll detect that it's an unexpanded VIC-20 and load the appropriate file browser. I'll go down to my VIC-20 folder. Maybe select some A games. And asteroids. The response time is not great. Okay, L turns. Oh goodness. Well, I stunk at asteroids at the arcade too, so that is good. We haven't tested out all the functions on the user port, but we'll get to that at a later time. Now I think we need to put the RF shield back on the bottom of this guy, get them installed in the bottom case, and then finish fixing up the top case. We've still got a few things to do there. As you might recall, our RF shield here was connected to the board with some conductive copper tape, kind of like this. And so we'll go ahead and replace that. What I've done is mark the locations where the tape needs to go on here. So I think what we'll do is chop up a couple of pieces of tape about the right length. And for these, I'm going to make a slightly thinner piece like that for the ones that go up toward the top of the board there, because there's not a lot of room there. Let's chop that in half. Those are probably too long, but it'll work. Okay. So now I wonder why they didn't use the conductive tape on the C64 rather than soldering it. Who knows? Oh, hey, you know what I did? I put this piece on the wrong side. Duh. Now, if we slip our board into place, do that. Well, my tape needed to be wider, didn't it? That's okay. We can make do. And for these two pieces, we can just put a second piece on top of that. That'll work just fine. We use this a lot at work for RF shielding, that type of thing. Okay, we are RF shielded. Now we can pop this back in the bottom cover. Our bottom cover cleaned up fairly well on this. All we really need to do is screw the board back in place. Always remember, on screws into plastic, go counterclockwise till you hear the pop and feel the screw kind of drop back down to the original threads, then go clockwise. Like that. Unless you're in the UK, of course, and then you have to start out going anti-clockwise, which I guess completely different than counterclockwise, which is counterintuitive. Just a joke, not a good joke, but a joke nonetheless. You might remember that the keys on the right hand side of the keyboard, the right side of those keys, got sun bleached. You can see the original color here where they were shielded by the white plastic top housing, and the normal color of that would be here. And a viewer suggested perhaps trying heat, like some people used to do with like automotive dashboards and things like that. You heat it up with a heat gun, it melts the plastic surface slightly and makes it shiny again. I wasn't sure how that would work on a key since they're smooth, but it gave me an idea, which I tried here. And you can see how much shinier this is. In fact, this is probably a little too shiny if we compare that to kind of the matte finish of a regular key, but it's certainly a lot better than the faded, and even the function keys on the right hand side of those are a bit faded as well. So let's run out to the garage and we'll see how we can get these cleaned up and closer to how they were originally. What that viewer suggestion caused me to think about was this headlight restoration kit. Basically, it comes with a little sandpaper deal here, and you sand the surface of the headlight. This is like 1000 grit. Then you use some plastic polish in this pad which goes on a drill, and you polish it. And I thought, well, you know, the thickness of the brown plastic on the outside here is, you know, nearly 1 millimeter, so I bet that could be polished. And basically I did the same thing. I took this little buffing pad with 1000 grit sandpaper, and you turn that into that. You can see it really scuffs up the faded part a little more than that, it looks like. Using this big buffing pad wasn't as convenient for something really small like the key, so I put a Dremel sized one in the drill. You don't want to use the Dremel tool, it spins so fast you will melt the key. Ask me how I know. Even on the slow speed, the Dremel's too fast. So you have your key that you've lightly buffed with the sanding pad like that. I'm using some Novus number 3 heavy scratch remover. I find this leaves a luster that is very similar to the normal key, whereas the Plastex left a much finer surface, which was just too glossy, too bright. It didn't look normal. Put some on there. We'll put some on our buffing pad. Making a mess here. Some all over our buffing pad. You got to watch for the little dry bits of the stuff. And then it gets really complicated. You just do this. I'm just going to do this a little bit so I don't splatter the camera. like so. You can see that needs some more effort. Now, if the key has printing on it, like on the front, none of these do, then you want to keep the polishing compound away from the printing, since this is a double shot, that's actually white plastic there. It wouldn't hurt that. Okay, that is a little more polished up now, and I found I have to go like 3 or 4 times through this process of sanding it with the 1000 grit thing here. And you notice the second time the part on the bottom, which showed up differently before, looks just like the rest of it. So we are making a difference. I'll go ahead and repeat this process a few more times and we'll look at the end result. And here is the result. This is the key we just polished. This is one of the same keys beforehand. And you can see that this looks pretty similar to the original non-faded color. And with the naked eye, you can see it's slightly different at the bottom, but if you don't know to look for that, you're not going to see it. And even on the function keys, it made a world of difference. I am very happy with how this turned out. I just have to do the rest of the keys. On the brown keys, it takes 3 times of sanding and polishing out to get the desired result. It seems like it's more like 4 times with these guys. I don't know if they got more sun or if it's just had more of an effect on this color. At any rate, I'm going to get busy and get the rest of these keys finished up. You might remember we had some cracks in the grill here. This is not uncommon on these VIC-20s that have the AC input because there's so much heat coming up through here, through the grill, that it tends to crack. And there's a variety of different ways we could, try to fix this, different glues that we could use. One is a glue used for plastic models, like this tester's glue. I did try this on one of these and it didn't stick very well. You may have better luck with other types of glue. Another is an epoxy. I have found that this doesn't work for little teeny tiny things like that as well. It does work very well for other things, which we'll see in a second. And yet another is some acetone. I have some acetone in a syringe here, and you can apply this very carefully in very small quantities. I have glued a few of these so far. This one, which kind of looks the messiest, I tried with the Moto glue first. It didn't stick, so I had to scrape off what I could and redo it with the acetone, and I've done these others. Now you can still see the crack. There's no avoiding that, but it is one solid piece now, and I need to do the rest of these. I've also done this one. There's all of these here to do, and when I am done gluing all this with the acetone, I 3D printed some little braces here which will go on the bottom, and we'll glue that on with the epoxy. Now we will also use the epoxy to glue on these repair tabs like this. Remember, this is the type that just has the little hooks here. Those almost always break. This is a repair kit I make to fix those. There are, I don't know, 7 or maybe 8 different bread bin case variations now, which all have different tabs. So I've been making 3D printed and CNC machine parts to fix the cases, so we'll glue those on with the epoxy. Now, what's the difference between these adhesives? Epoxy is a mechanical bond. It sticks in all the little surface undulations and things like that. So you want to rough up the surface that you're going to glue. Things like the model glue and our acetone is a solvent bond. It actually softens the plastic, and when you push the plastic then together, the softened plastic mixes together, and you've actually got a plastic on plastic bond there. That works really well for a lot of things. It'll seep into a crack, that type of thing. But one type of glue isn't the best for every situation, which is why we're going to use a couple different types on this case. Now we'll take a look at how I'm gluing the grill. I've got a separate video I did on installing the repair kits. I will put a link to it below. So I will get you the best shot that I can. I've got a container here which is PETE. The acetone doesn't attack it, so I'm using it to kind of prime the syringe like this. Squeeze that just enough to get a little drop out. That way I've got some right at the tip that I can kind of dab into the crack and let it draw out into the crack through capillary action. If you try to squeeze the syringe, you're liable to get way too much and flood the part and make a mess. So what I do is squeeze a little drop out into the container, and then I will try to separate the crack as best I can by pushing on it slightly, and then I'm just going to dab the syringe into that to let it try to draw some of the acetone out through capillary action. There, I just got more than what I wanted. What you don't want to do is get so much that it floods up to the front. And then I will push down like this and hold that for about 3 minutes. That's usually long enough to do the job. These things want to spring back apart, and there's no good way to hold it. So I will just hold it with my fingers. We have our freshly polished up keys installed back on the keyboard installed in the top cover. Got all our cracks up here glued. On the back side, I glued those little pieces I 3D printed with some epoxy in there to keep that from cracking more, hopefully. I glued in some repair tabs. This particular type is a 2B. Like I said, there's many different bread bin type cases. Another tip, even if you have your original tabs, is to take a small file and just slightly take the edge off this top corner right here. That'll make this go back together a lot easier. You won't have a sharp edge here running against a sharp edge there. I put some of this thin Scotch double-sided tape on the back of the case badges, and I'll get these put on now. I find this stuff works really good. It's about as thick as the original stuff, and it sticks really well. I even use it to stick rubber feet back on cases. And have some on the little badge too. I did not cut out the hole yet where the LED goes. Figured that would be easier to do once it was in place. Then I can just use a knife and cut it like that. Easy peasy. Now the only thing left to do is to pop the LED through the hole here and then put the case back together. Now we'll just get our wires hooked back up here. Give that a close. Make sure all our rear tabs snap in there like they should. Yep. Okay. All we have left is the 3 front screws, and we'll be done. Well, what do you think? I am just pleased as punch with how our little VIC-20 here came out. it looks like a completely different machine. It's not perfect. It's still got cigarette burns on it, and it's got some cracks in it, and it's showing some signs of age, but it works, and it looks pretty good, and we learned some new restoration techniques. Altogether a win, I would say. If you have any questions or comments, well, just leave them in that comment section down below. I would love to hear from you. Thanks to everyone for watching, and for the folks who help support the Hey Birt channel through Patreon and other means, it's greatly appreciated. Well, until next time, bye.